Let's talk about an inverting amplifier. An inverting amplifier is an op-amp circuit where the input signal goes through the negative or inverting terminal of the op-amp. In this configuration, we typically have a negative feedback loop. It's called the negative feedback loop because this loop goes from the output to the negative terminal of the op-amp. As part of the negative feedback loop, we have a feedback resistor, and we also have an R1 resistor in series with our voltage signal. We now need to algebraically find an equation for the gain of the op-amp, or the ratio between our voltage out versus our voltage in. Let's perform some nodal analysis. Like our non-inverting op-amp configuration, we can assume that the voltage at the negative and positive terminal are equal. This means that the voltage at this node is equal to 0. Therefore, we know the current through this branch is going to be our V source minus 0 volts all over R1. Our current through our feedback loop is going to be 0 volts minus V out, all over R feedback. There is no current going into the negative terminal of the op-amp due to its high input impedance. Thus, the current through our first branch must be equivalent to the current through our feedback loop by Kirchhoff's loop law. If we set our two equations equal to each other, we can see that the gain of our inverting amplifier is determined by our feedback and R1 resistors. The gain of this configuration is equal to negative RF over R1. This means our voltage out will be our source voltage multiplied by this fraction. Using what we now know about the gain of this amplifier, we can set up a simulation in LTspice to demonstrate this principle. If we have an RF resistor equal to 10 kiloohms and an R1 resistor equal to 1 kiloohms, then that means we will have a negated gain of 10. The output of this configuration is 10 times as large as the input, but negated. That is why when we start with 100 millivolts, our peak reaches 1 volt. This is why it is called an inverting amplifier. Because of the simplicity of the gain equation, inverting amplifiers are often used in a multi-stage configuration. In this example, I have just added another identical stage to my circuit in order to get a gain of 100. Each stage has a gain of negative 10. Thus, the final gain seen at the output is just negative 10 times negative 10, which is equal to 100. This is why our final output is once again positive and not an inverted sinusoid.